Normal distribution is one of the distributions we use quite frequently in this course, and again we are talking about distribution which is symmetric for normal distributions, and the distribution has only two characteristics, which is the mean and the standard deviation. As you can see, there is no skewness because the distribution is symmetric, so not skewed in any particular direction. There are no fat tails. It's quite smooth and merging into the horizon. For normal distributions, many things in life follow a normal distribution, or apparently a normal distribution, or quite close to a normal distribution. For example, the probability distribution of IQs, or intelligence quotient, a score you can obtain by taking an IQ test, has been found to be quite normally distributed in the population. Okay, so in this case, for example, an IQ score of 100, which is right in the middle of the normal distribution, so you can say that that's the mean of the distribution, or the median, because for normal distribution, the mean and the median are exactly the same. But of course, there is a variability that some people have more than 100 and some people have less. And again, the variability could be measured by using standard deviation, which is something we learned in the previous module. So, again, if you remember, the mean is represented by mu, a Greek letter you will often come across. But overall, you see it's a symmetric distribution around that mean. Okay, so you can say there is because the mean is the same as the median for a normal distribution, that 50% of the population has an IQ score of below this mean, or 100, whatever we saw in the previous slide, and 50% have above mean scores, or more than 100. But the probability of someone having an IQ score between the top most score and the bottommost score is again 1, which is the golden rule of probability. Okay, so probability of all people in the population, if we just add them up, most people you would say are more likely to have a mean of a score which is close to the mean, which is more likely than other events, like 50% here. So more people will be having scores which are very close to the mean. But as we go towards the tails of the distribution, very high IQ scores as well as very low IQ scores, the probability goes down and down until it almost merges into the horizon. So the extremes are more unlikely. The more likely events are close to the mean or the median. So let's look at some more examples of normal distribution. A problem here is of a canning company, okay? And the canning company in this case basically fills up tomato cans, and the tomato cans are sold with a labeled weight of 400 grams. So this is peeled tomatoes. However, if you just pick up randomly a can from the supermarket, it may not just weigh exactly 400. Because there are variations in the size of the tomatoes, and there is always a little bit of variation you'd expect from what they advertise as 400 grams. However, let's say the year-long experience has indicated that the weight of the fill in the cans is normally distributed. So although they are a little bit different, but their mean is 400 grams. Okay, so the average weight of different cans, if you pick up, is going to be about 400. But there's a variability of 10 grams because individual cans vary from that average, or may vary from that average. Okay, let's assume the distribution is normal, as we just saw in the previous slide. All right, so a normal distribution with an average weight of 400 grams and a standard deviation of 10 grams. Now, you suppose somebody asks you this question, that what is the chance that if you just randomly pick up a can from the supermarket shelf, that it will weigh between 400 and 420 grams. So given the information you already have, so these kind of problems could be, again, easily done in Excel, just like we did for binomial distribution. Here we use a function called normdist instead of binomdist. Before we go there, we just would understand the problem a little bit more in a visual sense, that this is what you were asked, that this is the whole area Okay, so all the cans would lie somewhere in this distribution. Okay, but obviously you'll have less chance of getting extreme weights, variation of weights, and less chance of getting cans which are very, very underweight or overweight. What you are being asked is, what's the probability that the can would be between some 400 and 420? So that is the area which is being indicated by this this blue zone. Okay, so we are asked to find out what's that blue zone's area in the overall scheme of things. So it could be done in different ways. There are mathematical formulas, Z tables, but we would be using something in Excel, which is the third option, and which is the option commonly used by people these days. So I'll straight away go to Excel to show you the normdist function. So if you bring up normdist function, so again, we click on function, insert function, and choose the function we want. Again, under statistical, you can find function normdist or norm.dist. That's the one we are looking for, norm.dist. And if you click OK, it again asks you for a few inputs, and first of all, it asks you what's the number you are concerned about. And in this case, we have, of course, two numbers between 400 and 420, but we start with only one because we can input only one here. So we use the number 420, and then the inputs are fairly standard. It asks you what's the average of the distribution, which in this case is 400 grams. So we put 400. Standard deviation is given to us as 10 grams. We put that. And again, the last field, like by normdist functions, it asks you whether it's a cumulative number you want or a non-cumulative. We invariably use cumulative, yes. So just type yes or type 1. So once you do that, what you would get is chance of getting a can which is weighing less than 420 grams, because we have used the number 420 in our field, first field, and just like by normdist function, normdist functions also give you a certain number or less than that number. Okay, so if you are trying to find out what's the chance of a can weighing more than 420, you have to do a little bit of manipulation, because Excel always gives you less, the probability of getting a number less than a certain number. So use 420 here. So what we get is chance of getting a number less than 420, or chance of a can weighing less than 420 grams in this case is 97%. Okay, so that's the chance of a can weighing less than 420. However, you have been asked to find out the chance of getting a can between 400 and 420. So what we got here just now is chance of cans weighing less than 420, which means all the area on the left-hand side of 420. But you only want this blue area, not all area. So you have to take out the white portion from here, which is chance of cans weighing less than 400. Now you can again go back to Excel and do that, but in this case I won't do this, because you all know by now the chance of a can weighing less than 400 is going to be 50%, because it is a normal distribution and 400 is the mean, which is also the median. So I won't bother to do this in Excel. I will simply assume that this is 50%, this white area. So if everything below 420 is 97% and this white area is 50%, then the blue area obviously is the difference between the two, which is about 47% or close to 48%. So that's what would be the chance of picking up a can from supermarket shelf randomly and finding out that the weight is between 400 and 420 grams. So that's how normdist functions are used, just like binomdist functions. And similarly, if somebody asks you that what's the chance that the can you pick up would weigh more than 420 grams, then you can simply go there and manipulate this on the formula bar by putting 1 minus because norm-dist function has already given you the chance of weighing 420 or less. So 1 minus that would be more than 420 grams. Probability is very small, about 2%. You can see that here. So this is using norm-dist function in Excel. So that basically sums up what we wanted to learn about normal distribution. They have only two characteristics, the mean and standard deviation. That basically defines a normal distribution. And once you have those two inputs, you will be basically able to describe what a normal distribution is. We'll be using a lot of normal distribution in the future modules in this unit. Thank you.